I'm going to talk very, very quickly just a couple things about proteins. One of the things that makes proteins very different from carbohydrates and lipids, which you've already discussed, is that proteins, they're going to be composed of carbon, hydrogen, and oxygen, just like lipids and carbohydrates. But proteins are also going to be composed of nitrogen. They're going to contain nitrogen. So when you think of proteins, they're going to be carbon, hydrogen, oxygen, and you're going to have that nitrogen added onto them. So that's going to make them just a little bit different in how they're composed. Proteins serve so many varied functions in the body. They're very, very crucial. One of the things that they do, they act as enzymes. Enzymes are very important because they speed up chemical reactions. They allow chemical reactions to occur at a rate where they can keep up with our body's needs. So without proteins or without these enzymes, our bodies couldn't keep up. We couldn't keep up with any of the reactions that needed to take place. Proteins also are important for immune functions. Your antibodies are proteins. They're important in transport. They're important in maintaining balances, acid-base balances, nitrogen balances in the body. They're also one of the phrases to remember with proteins actually is growth and maintenance. So they're very, very important in the growth of the body and in the maintenance of overall health of the body. So very different functions with proteins. All of them are very, very important. Now I mentioned that proteins are composed of carbon, hydrogen, oxygen, nitrogen. And your basic component of proteins, those guys are going to be called amino acids. So proteins are going to be based of amino acids joined together. So that's what's going to form a protein, or amino acids joined together. Now what an amino acid is it's a molecule. It's going to have a central carbon. It's going to have a hydrogen coming off of it. It's also going to have an amino group and a carboxyl group. The amino group is where the nitrogen comes in. And then you're going to have a carboxyl group. It's also called the acid group. So that's how you get your amino acid. And so those are the three groups that come off of the central carbon. If you remember anything about chemistry, carbon's going to have those 4 bonds that it can make. That 4th bond that comes off the carbon, that guy's going to be called your R group, your side group, or side chain. I believe that I refer to it in your notes as the side group or the side chain. That group is going to be different for every amino acid. So in 3 with the central carbon, and then 3 of the bonds that come off are going to be the same for every amino acid. What's going to be different is going to be that side group or that side chain. And we're going to have 20 different amino acids. And these guys are all going to differ in those side groups, those side chains. And the amino acids are going to join together. They're going to be linked by peptide bonds. And that's what's going to form your protein. Now, the order of these amino acids, or the sequence of these amino acids, that's how you're going to get so many different proteins. They're very different. They have all these different kinds of jobs, so obviously they're going to be different. And that has to do with the order of the amino acids. So with 20 guys to work with, there are lots of different orders that we can come up with. One thing that's really important about proteins is that they have to be the right shape. And their shape's going to be determined by the order of the amino acids. But the shape of the shape of a protein, because the shape of a protein is determined by the order of those amino acids. Protein has to be in the right shape to work. The shape of a protein is going to determine its function. So if a protein is not in its right shape, it can't work. It cannot do its job. So proteins have to be in the right shape. And what makes that important is a term that ties in with this is a term called denaturation. So when proteins are what we call denatured, or they undergo denaturation, what happens is they're going to be bonds broken. It can be done by heat, by acids, and what's going to happen is that this shape is going to change. Bonds are going to be broken, the shape is going to be changed, and the protein can't do its job. So once proteins are denatured, they're not going to be able to do their job. So that's very important in regard to proteins. One other quick thing about amino acids. We said there are 20 different amino acids. We said they all differ in their R group or their R chain. We have a grouping of amino acids. We can group them by whether or not our body can make them. If our body can make an amino acid, it's going to be a non-essential amino acid. So non-essential amino acids our bodies can make. Essential amino acids our bodies are not able to make. And because our bodies are not able to make them, we have to get essential amino acids from our diet. So that's why those guys are important. The essential amino acids we have to get from our diet. The non-essential ones, our bodies are going to be able to make those, to build those. So remember, proteins, the shape equals their function. Building blocks of proteins are your amino acids, and the building block, or the amino acids are the building blocks of the protein. But the macromolecules that build up the protein, or the atoms that are going to build up the proteins, carbon, hydrogen, oxygen, nitrogen. So with your lipids and your carbs, it's going to be carbon, hydrogen, oxygen. and then proteins, carbon, hydrogen, oxygen, nitrogen. So you can't forget about that nitrogen guy who's on there, because he plays a lot of different roles and allows these proteins to be able to do different things that your lipids and your carbs can't do. Thanks so much.